A dream written down with a date becomes a goal. A goal broken down into steps becomes a plan. A plan broken by action makes your dream come true. Welcome to all gathered here this evening. It gives me immense pleasure in welcoming every one of you to this online summer course on unmanned aerial vehicles. I now extend a warm welcome to our resource person for this evening, Mr. Pradeep, on behalf of our expected college, Chairman Sri T. Duraisamy, Vice Chairman Sri D. Parandaman, Secretary Sri D. Dasarathan, Joint Secretary Sri S. Gopinath, Correspondent Sri S. Ambarnath, Director Sri S. Sabarinath, our beloved Principal Dr. S. Ramachandran, Head of all UG and PG departments, professors, faculty members, and students of our institution. Mr. Pradeep is a project intern at Indian Institute of Sciences, Bangalore, and is currently working on design, analysis, and fabrication of unmanned vehicles. He was a research intern in IIT Indore and a student intern at Maruti Suzuki Service Masters, Chennai. His technical proficiency include Catia V5, Autodesk Fusion 360, P- PTC Creo, and ANSYS Workbench. Thank you, Mr. Pradeep, for joining with us today. Before we begin this event, let me share a brief introduction of our institution. Dharmanaidu Educational and Charitable Trust established SA Engineering College in the year 1998-1999. We are an ACK A grade and ISO 9001-2015 certified institutions located at Tiruvekad. All our departments are NBA accredited. We are working autonomous from 2019 for a span of 10 years. We have 24 years of excellence with 9 UG programs, which include BEECE, EEE, CSE, Civil, Mechanical, and BTech IT, Artificial Intelligence and Data Science, Computer Science and Business System, along with 6 PG programs, which are ME CAD CAM, CSE, Communication System and Embedded System Technology, MBA, and MCE. We also support various doctorate programs in CSE, ECE, EEE, Mathematics, and Mechanical Engineering. SA Engineering College stands out in the crowd for its Anna University recognized research centers with 27 funded projects where students get chance to work on these projects. We provide highly comprehensive placement of about 90% each and every year. We have achieved 90% of placements even during this pandemic in the year 2020-2021. Our top recruiters include Avasoft, Rapid Data, Emphasis, Infosys, Capgemini, CTS, TCS, Zoho, L&T. We have introduced the latest courses on artificial intelligence and data science, CSE, and business systems. We have a state-of-art infrastructure, including Internet of Things Lab, Product Design and Development Lab to conduct research projects. SA Engineering College maintains high standard of education by providing a wide array of world-class academic facilities, employing high qualified and expert faculty members, and creating an ambience of conductive quality education. I now request our resource person to take over.
Pradeep, you can start right now.
Very warm wishes to everyone. Before moving ahead, I would like to thank the person who gave me such a humble welcome note. And this course is basically on introduction to unmanned aerial vehicles, the technology which I've watched and got fascinated only because of which I got into it and I've done all my internships based on it. Before diving in deep, we'll just know what unmanned aerial vehicles are. And I can assure you that while before leaving the session, you'll be gaining some amount of knowledge about UAVs, and it won't just be theoretical but also be practical oriented stuff. Unmanned air vehicles are generally remotely piloted or autonomous aircrafts which can carry payloads such as different sensors, cameras, and communication equipments. Their applications range from food delivery to air ambulance applications. But before, like I mentioned earlier, let us start off with the basics. The mission of UAVs is to just perform critical flight operations without risk to the personnel who are doing it actually, and also to cut off the cost to a huge extent. For example, in today's life, we might be aware of our fighter aircrafts, which is being operated by our pilots who are very well trained by the specialist organizations. Whereas recently DRDO had tested their Swift aircraft, which is a part of Gatak program, and it proves the level of autonomy which we have attained still now, and it also has the ability to catch on with the dogfights in midair. And moving on next, generally civilian UAVs is designed to perform a particular mission at a lower cost and uh, also provides us with higher impact when compared to the manned aircrafts. In the recent past, the trends show that the research in UAVs has grown a lot, especially in the past couple of decades. Moreover, both the fixed wing and rotary type of UAVs have seen a drastic improvements when compared to the last 30-40 years. Moving next, let us first get an idea about different types of unmanned aerial vehicles. In the top left corners, we have the fixed wing UAVs. And next to it, we have different type of multicopters. Multicopters is nothing which has different rotor crafts to just help you fly in air or just to hover and perform different maneuvers. Multicopters are classified into bicopters, tricopters, quad, hexa, and octocopter. When we combine both fixed wing and octocopter, we get into hybrid VTOL UAV. Multicopters aid us by providing vertical takeoff and landing abilities, whereas fixed wing UAVs are very well known to provide higher range and endurance. Endurance is nothing but, to just get it down into simple terms, it is the amount of time which we can fly. Whereas in multicopters, the amount of flight time is very less. But the disadvantage with the fixed wing UAVs is that we either need to hand launch it, or it needs a runway to take off from the base station or the ground station. So while we combine multicopters and fixed wing UAVs, we get hybrid VTOL UAVs. Hybrid VTOL UAVs is nothing but the combination of multicopters and fixed wing UAV, which offers us vertical takeoff and landing. Once we take off, we'll just switch on to the fixed wing mode, where the propulsion system for fixed wing turns on, and we can thereby like extrapolate huge amount of endurance and range when compared to multicopters. Up next is single rotor UAV on the top right corner. Single rotor UAVs are just similar to the helicopters, which you can see in the commercially available market. They too have their advantages and disadvantages. Their major advantage is similar to the fixed wing UAVs. They are very much cost effective and also have very good endurance and range. Whereas the disadvantage part comes because of the complexity involved in the mechanism or the transmission system. Moving up next, let's just learn deep about the fixed wing UAVs. Fixed wing UAVs can be used for flying as a hobbyist, or they are also used in various other applications. For example, here the UAV which is presented to you is the Skywalker UAV, which is hand launched. Generally, fixed wing UAVs use the wings to generate lift, and the geometry is designed in such a way with the airfoils. It is very aerodynamic and it satisfies our need. About the airfoils and about the basics of airfoils and the flight physics, will be covering it up in the upcoming sessions. Next is the hybrid VTOL. As mentioned earlier, this category includes a wide range of aircraft, which includes helicopters, thrust vectoring fixed wing aircraft, and hybrid aircraft with powered rotors. The major advantage, as I mentioned earlier, here we have hybrid VTOL, which is presented here on the left side of the slide. Here you could see it is the H configuration with a propulsion motor at the rear part of the aircraft. Here, using the four motors present in the H configuration, we can take off. And once we reach the certain altitude, we can transition to forward flight, where all the four motors turns off and we can cruise efficiently towards our mission requirements. And as we mentioned earlier, there have been huge developments in this particular range of UAVs. The extent of development is that in very few amount of days or years, we'll be able to use air ambulances or air taxis, which are already applicable in certain countries. And next, a tricopter. Generally, tricopter consists of three motors. uh, as the name signifies, tri is nothing but 3. And to maneuver efficiently, it uses a servo in the rear rotor to compensate the torque again, which is similar to the helicopters. Even the helicopters has a rotor in the rear part just to counter the torque created. And then here comes the quadcopter, which you would have come across very frequently, and it is very good for hobbies to start off with. A quadcopter, sometimes known as a quadrotor, is a four-rotor aircraft, as mentioned here. Despite the fact that quadrotors and helicopters and convertiplanes had long been flown experimentally, the arrangement remained a mystery until the emergence of the contemporary UAV or drone. For example, in the recent days, the being practical, we have been seeing so many people getting into this field, not just as professionals, but with the eagerness to learn about these things. It is a very good atmosphere which is being created. And because of the tiny size and low inertia of drones, a very simple flight control system may be used. As you can see in the picture, if you just get an Arduino board, and you can also get a ready flight control program available in GitHub. Just plug into the Arduino board, dump the code, and get the hardware system ready. And you yourself can assemble a quad rotor drone and understand the dynamics. Also, you can also learn flying. Up next is Hexacopter. As the prefix mentions, Hex has 6 rotors with it. And hexacopters, how are they different with quadcopters? They are strong, lightweight aircraft that can transfer larger payloads when compared to quadcopters because they're very steady on air. And these hexacopters are ideal for aerial photography. There are so many drones available in the market like DJI Parrot drones. All those have been using quad rotors. But one advantage with the hexacopter is that even if one of the motor fails, we could get the total system safely into the land. Whereas the if any one of the motor fails in quadcopter, it will be a very big hassle to get back the total system to the land, and it might be catastrophic. We'll be losing a large amount of money which we had invested. Moving next, we have octocopters. Octocopters are basically UAVs that can fly in multiple directions simultaneously. Octocopters are basically Sorry for the interruption. Yeah. Moving on with the octocopters, the majority of octocopters utilize for complex and long-term applications. Given the number of rotors and hefty nature, most of these drones provide excellent stability and vibration-free operations, only because of which they have been widely used in aerial photography applications. Up next, will be going through the classification of unmanned aerial vehicles based on the UAV class, weight, and size. Adding to it, we'll also be learning about the operating altitude, range, and endurance. First in the list is micro class UAVs. The weight it's nearly lesser than 0.55 lbs. Speaking about the size, it's very lesser than 10 centimeters, and their operating altitude is relatively high. Range is around 0.1 to 5 kilometers, which is like 100 to 500 meters. Speaking about the endurance, it's very much lesser than an hour. That's because the battery technology available till date is not sufficient to satisfy our needs for longer endurances. Up next is Mini, which is around 0.55 to 2 lbs. Their size usually varies from 10 to 30 centimeters, and the operating altitude is lesser than 500 feet, and range is from 500 meters to 1000 meters, which is nothing but 0.5 to 1 kilometers. And their endurance is also restricted to one, less than an hour. Moving next is very small or nano UAs. Their weight is generally limited to 2 to 5 lbs, and their size is around 30 to 50 centimeters. And their normal operating altitude is less than 1000 feet. Range usually extends from 1 to 5 kilometers. And when compared to micro and mini UAVs, their endurance is a bit higher, which ranges from 1 to 3 hours. And up here, I might love to share an information. The DJI Mavic Pro comes under the class which weighs under 250 grams. So we don't need any registration from our side to the government. The reason being that all this weight categorization is done for the lawmakers to ensure and just label the number of drones which is being operated in our country, as they may also might be a threat for the defense forces or the civilians living nearby. Up next is the medium class UAVs. The weight generally ranges from 55 to 1000 lbs, and the size is from 5 to 10 meters. Speaking about the operating altitude, it varies from 10,000 to 15,000 feet. And here comes the very big difference when compared to the other class of drones. Their range is very high, which is from 500 to 2000 kilometers. And the endurance is based upon the propulsion system which we use. When we use electrical propulsion system, their endurance sometimes get cut off to a huge extent. Whereas when we use IC propelled or any other sort of propulsion system, we can procure high amount of endurance, which can be seen here, which is around 3 to 10 hours. Up next is large. Large class of UAVs, and their weight limit is from 10,000 to 30,000 lbs, and the size is from 20 to 50 meters, as it sounds to be very huge. And their operating altitude is 20 to 40,000 feet, and the range varies from 1,000 to 5,000 kilometers. Endurance, speaking about the endurance, these class of UAVs can be like very useful in missions where we need to attack our opposition who's like let's say 2000 or 3000 kilometers from it. Or to make it into simple terms, war between two countries, they'll be using a large scale or male class UAVs. Male class will be called, like, looking onto it in the following slides. And up next is tactical or combat. As I mentioned earlier, recently DRDO has tested a Swift UAV. It's nothing but a tactical or a combat unmanned aerial vehicle. The job which is being done by the current pilot in a fighter aircraft will be autonomously being carried out by the tactical or combat UAV with the help of a manned fighter jet. Up next is MALE. MALE is also called as medium altitude long endurance UAV. The weight is from 1000 to 10,000 lbs. The size usually varies from 15 to 40 meters, and the normal operating altitude is from 15,000 to 30,000 feet, and the range is from 20,000 to 40,000 kilometers. And the endurance is very high, which is maximum at 40 hours. Hail. Hail is nothing but high altitude long endurance UAVs. The weight is more than 5,000 lbs, and the size is from 20 to 50 meters. Normal operating altitude is 50,000 to 70,000 feet, and the range is similar to male class UAVs, but the endurance is very high. A Hail class UAV, which is manufactured by an US based company, has successfully flown from the United States of America to the other continent of the world, which is Australia. And that is only because of the high cutting edge technologies they have. And India is also looking on to procure those drones to be added on to our defense forces. And up next is we have quadcopters. Quadcopters, again, as I mentioned earlier, it has four rotors in it. The weight generally varies from 0.5 to 100 lbs. There are more than that too, which are again classified into heavy quadcopters, which is used for cinematographies to lift heavy weights and stuff. And up next is helicopters, which is a rotary wing. Generally, their weight is at a maximum level of 200 lbs. Their size is from 13 to 2 meters, and their operating altitude is less than 500 feet. Endurance can vary, as I mentioned earlier. They're very aerodynamic and efficient when compared to the quadcopters, hexacopters, or octocopters. But they're very efficient and aerodynamic, which ensures them that they provide us with an endurance of 10 minutes to 2 hours. Now, let us just have a look onto different class of UAVs with an example. As you can see here, this UAV is named as Global Hawk. Global Hawk is nothing but a high altitude, long endurance UAV. Its first flight was carried out on 28th of February 1998. The wingspan is extending up to 39.9 meters. Higher the wingspan, higher the lift you generate. And up next, the length of the fuselage is around 14.5 meters. Their maximum takeoff weight, as recorded, is 14,620 kg, which is around 14 tons. The range is up to 22,779 kilometers. As I mentioned earlier, these Global Hawk is manufactured in the United States of America, which has successfully completed its flight from the US to Australia. Their endurance is 32, it's more than 32 hours, and their service ceiling is 60,000 feet, and it can record a maximum speed of 630 kilometers per hour. Up next in our list is RQ-1A Predator. It is in our bucket list in the recent budget of our government. And these UAVs belong to medium altitude, long endurance aircraft. Its first flight was carried out on June 1994. The wingspan extends up to 20 meters, and the length of fuselage is 11 meters. MTOW is something which includes the fuel it carries, the avionics, the payload, and the structural weight itself. And the maximum takeoff weight here is 952.5 kg. You could have known the difference between the HALE class maximum takeoff weight and the male class MTOW maximum takeoff weight as of now. The range is 1,240 kilometers. Speaking about the endurance, it's lesser than HALE class, which is high altitude long endurance UAV. Here it is just 25 hours. The service ceiling is also very low, which is when compared to the HALE class, which is just 26,000 feet. The cruise speed is recorded around 166 to 170 kilometers approximately. Up next is small class UAV. Bayraktar is a very famous name as of now because they have been very widely used by Ukraine in the Russian-Ukraine war. Bayraktar is a small class UAV as mentioned, and the wingspan is around 1.6 meters. The length of the fuselage is 1.2 meters, and the MTOW is very less, which is around 3.5 kg. Endurance is greater than 60 minutes as it uses electric propulsion system and due to its aerodynamic body. Service ceiling is just 300 meters and its cruise speed is recorded to be 70 kilometers per hour. Up next is Mosquito UAV. The name might be very funny, but these UAVs have limited amount of applications, which again is a UAV belonging to very small class, and the wingspan is around 0.35 meters, and the length of the UAV is again 0.35 meters, which is around 350 mm. And the MTOW of this UAV is 0.5 kg, and it provides us with an amazing endurance of 40 minutes, even though being propelled by an electric propulsion system. The range is around 3 kilometers and its cruise speed is 46 kilometers per hour. And this is one of the most exciting part or the exciting UAV which fascinates me a lot when it comes to the modern developments. This unmanned combat aerial vehicle, which is named as X-45A, is developed by Boeing, and the wingspan is nearly 10.3 meters, which is really huge, and its length is around 8.08 meters. Its empty weight is around 3,629 kg. The range is 2,405 kilometers. The recorded service ceiling is 13,200 meters, just to ensure that it is not detected by the enemy's radar. And the cruise speed is around 987 kilometers per hour, which is really tremendous, and it's powered by turbojets. Here, these UAVs are designed in such a way that they are pretty much with tailless, and they also satisfy the stealth requirements. Stealth requirements in the sense the it shouldn't be detected by the enemy radar when they send the signal off. And you could see here the profile is very much sharp in the edges. It's because whichever signal or the radar signal is being dissipated from the ground, it should be reflected towards outwards and not towards the radar station. This ensures that the UCAV remains undetected in the enemy's radar, and it can carry forward the mission which is prescribed. And at last, it's Epson micro flying robot, and it belongs to micro class. The power consumption is very less, which is around 3.5 watt, and the mass is around 12.3 kgs. The flight time is estimated to be 3 minutes, and the diameter of the propeller is around 136 mm, which is 13.6 centimeter. The complete height of the system is around 85 mm. And we could have also come across a recent uh, success of NASA of flying their similar class of UAV in Mars, just to gather some data and proceed on with future developments. And before diving in further deep, let's understand the motions of an aircraft. The picture in the left denotes the different axes and the motion which you can do. The z-axis is generally prescribed for yaw, and the y-axis is for pitch, and the x-axis is for roll. The video here will just give you an idea about the roll axis, pitch, and yaw axis. Here the pitching is happening, and you could also see that in the pitch axis, it is majorly determined by your elevators, and the roll is determined by your ailerons, and yaw is done with your rudders. Here, as I told you earlier, we learn about the airfoil nomenclature. Airfoil is nothing but aerodynamic geometry which is used in manufacturing wings, and it is also a major part in creating a proper amount of lift for our aircrafts. In this geometry, we have a leading edge radius based on which the complete airfoil is designed. The forward section of the airfoil is named the leading edge, and the rear is the trailing edge. The length of the airfoil from the leading to trailing edge is known as the airfoil chord. And in the right side of the slide, you could see different types of the airfoils. The first is a symmetric airfoil where there is zero camber, which means that the line joining the leading edge and trailing edge is very straight without any deviations. And in the next picture, it is the asymmetric airfoil or cambered airfoil. You could see that there is a very little amount of curvature in the bottom, which is also called as the positive camber. And the third picture, it has a negative camber because the chord line is below the maximum camber line. So these are the very basic differentiation of airfoils, and you have also learned about the airfoil nomenclature here. Up next is the physics of fixed wing UAV when it is not either climbing or banking. That is why it is named as steady level flight. And the image here shows you the different components acting on an aircraft. Lift is perpendicular to the self weight, and thrust is just parallel to your drag. On resolving the components, here we get lift is equivalent to the weight and drag is equivalent to the thrust. Lift, the formula for lift is nothing but half into density into velocity of the free stream air and into the wing surface area into the lift coefficient. Lift coefficient is nothing but the amount of a constant which signifies the amount of lift which a particular airfoil can generate. And this lift is equivalent to the weight, which simply means that the wings must be able to generate the amount of lift which must be equivalent to the weight of the total aircraft. And up next is the drag. When choosing a propulsion system, we should keep in mind that we should overcome the drag produced by the velocity just passing through our system. So here the drag equation becomes equivalent to the thrust. Drag equation is pretty much similar to the lift equation. The only thing which varies here is the coefficient. In lift equation, we use lift coefficient. Whereas in drag coefficient, we use CD, which is nothing but a drag coefficient. Up next is the physics behind multicopters. Multicopters is a very exciting concept when it comes for me. And let us have a very small activity here. It is just to find out the amount of thrust to be produced by each motor for a quadcopter, which weighs around 2 kgs. And the application here is just to hover. Let's get in deep. Generally, a quadcopter has 4 motors, as you can see here in the picture, and uh, which literally means each motor must be able to produce equal amount of thrust to attain steady flight or hover. Thus, here we have the thrust, which is equal to total mass divided by number of motors. Our total mass over here is around 2 kgs, and divided by the total number of motors, which is 4, we get around a thrust of 0.5 kgs. So while sizing our propulsion system, we should ensure that we procure a motor which can produce thrust around minimum of 0.5 kgs or 500 grams. And while hovering, the thrust to weight ratio is said to be 1. Adding to it, generally, our application while using multicopters is not just to hover, but also proceed on with certain applications. To maneuver accordingly, we need a thrust to weight ratio of 1.2 to 2. So at that time, we might need a thrust levels of 1 kg to be produced by each motor to attain a thrust to weight ratio of 2. And here we come into the design part. If you want to be a UAV designer, you will have to follow the uh, following 10 parameters before starting the design. Number one is your production cost. Whenever you get into a project, first thing which you'll have to estimate is the amount which you'll have to get from the funding agency or the person who's funding you. Up next is performance. Performance of a passenger aircraft and a fighter aircraft is completely different. So this is where we'll have to seal our opinion on and move further. Up next is a flying qualities. As mentioned earlier, a passenger aircraft won't be performing high maneuvers. Its application is just to transport passengers from one state or a country to other place. Here, the major the major thing is to ensure the comfort of the passengers. Whereas in a fighter aircraft, it is completely different. There is nothing to do with the pilot's comfort. And in the recent times, you might have come across the Top Gun movie where you could have learnt about 10 Gs of load acting on an aircraft. And it's very hard to take up that loads. And this is why the fighter jet aircraft pilots are highly ranked wherever they go. And up next is the design period. Not just in designing a UAV, any project which we take up must fall in a constrained time period within which we'll have to plan our activities and perform manufacturing. And next up is the look of the platform. Look of the platform is nothing but the aesthetic look or how beautiful the aircraft which you have built is. The customers in the market won't just be looking on to the performance or technical specification of aircraft. It is also about the aesthetic look, which is very important. And up next is the maintainability. Any product which we buy is not just about its performance, cost, and everything, but also it's about the maintainability. Let us say, for example, if we have a laptop or a television, and if there is any sort of glitch happening, we should have an access to overcome it with either with help of a technical person or on ourselves. But in case of UAVs, it's very complex. This is where we should ensure that it is modular and there is no complex mechanism involved in an UAV. Up next is producibility. Uh, Speaking about the airfoils, there are different kinds of airfoils, but majority of selection goes into the airfoils with simple geometry, just to considering the production abilities of the plant or the organization which we are based on. So producibility becomes a very important thing. And till date, we might have heard about the Kaveri engine and stuff. And Kaveri engine is a very big milestone project which is carried out by our Indian agencies like Hindustan Aeronautics Limited. And the reason why we haven't come out with that is just because of the hindrances which we have with production, and it is majorly caused because of the lag in technology in our country. And up next is the overall weight. Overall weight is a major parameter which determines the length of your wing, the propulsion system which you choose, and the amount of fuel or the batteries which you will have to carry on board. And up next is the disposability. Any product which we design will come to an end. Generally known, a product introduced into our market that gets into steady growth and enters the maturity stage and starts declining. And the maturity stage is where we start earning a lot. Here, earning is not just the only requirement. When the project gets into the declination stage, all the products which we have designed comes back to us, where we must take the responsibility of disposing it safely without causing any hazards to the edge. And up next is stealth requirements. Stealth requirements does not imply for every aircraft which we design. Stealth requirements is based on the design requirements. Like for unmanned combat aerial vehicles, we need stealth requirements just to avoid radar detection. And again, while designing stealth aircraft, there are different design parameters which we should contain and look onto. Up next is UAV life cycle. Like any product, UAV is to have a general life cycle. Starting off with this conceptual or preliminary design, we'll be moving on into detailed design and development, where we'll be working on the computer design, high fidelity analysis using computational fluid dynamic softwares, static structural analysis, and again we'll be getting into conceptual and preliminary stage, where we'll be optimizing our design again and again. And up next is our production stage. Production is the very end stage, but before that, we would have gone into so many iterations just to satisfy our design requirements or the requirements provided by our customers. All these three stages, starting from conceptual, moving on to detail, and at last the production stage, it is called as the acquisition phase. And at last, it is the utilization phase. Once we produce our UAV, we'll be introducing to our market, where it will be drastically used, and we'll have to give support for in terms of maintenance, technical malfunctions, or anything. And up next is the phase out and disposal. When it comes to disposal, again I would like to stress a lot on this. Disposal stage is very important. We should also look on to recycling certain parts and also dispose it safely without any hazard to the nature. In the conceptual stage, what will we do? We'll start off with the UAV design requirements. These design requirements include the mission, performance requirements, stability of the system, controls, cost, operational time, and the time required to manufacture it, and the payload. Payload is a very important thing here. For an aerial photography drone, the camera itself is a payload there, whereas an air ambulance, the medical stuff which it carries is a payload. Once we are done with the design requirements, we'll be identifying major components of the UAV in such a way that it satisfy our design requirements. Certain parameters are the wing configuration, tail configuration, fuselage configuration, landing gear, engine, autopilot, and the payload configuration. Once we are done with that, here comes our engineering graphic skills. We'll start doing our conceptual design. It must be creative to get different layouts ready. Once that's done, we'll be doing trade-off analysis, where we'll be getting an optimized configuration. Once we are getting certain number of optimized configuration, we'll be finalizing on our UAV configuration, which is the final one. Once the configuration is selected, we'll be moving on to the preliminary stage. Here, we'll be calculating the UAV performance design requirements. Things like our maximum speed, range, endurance, rate of climb, takeoff run, stall speed, and payload. When it comes to hybrid VTOL systems, we don't need takeoff run. Instead of doing takeoff run, what we'll do is take off with the multicopter system which we have, which is nothing but quadcopter incubator to a fixed wing UAV of different configuration. After that, we'll be again determining the maximum takeoff weight of a UAV using certain formulas. And once that's done, we'll be moving on to the wing area. As I mentioned earlier, in steady flight, the lift will be equivalent to our weight. Here, the wing must have sufficient area in order to generate some amount of lift, which is also capable of uh, carrying the self weight of the total UAV. Moving next, we'll be choosing the engine based on the overall weight of our aircraft. The engine selection can be either propelled by IC or jet. And again, moving on to the electric propulsion, we'll be calculating our power required. And up next is the determination of autopilots. Speaking about autopilots, there are wide range of autopilots available in the market, starting from Ardocopter, Pixoc, and Micropilot. There are so many, and certain things can also be self-developed. Most of the organizations just procure an autopilot and make minor changes to it, and they adopt it for their own applications. As an output, what we'll get from the preliminary design is the overall takeoff weight of our system, our reference or the wing area, and the engine specifications. And there might be a question, why should we perform design requirements? For example, if we have a startup where we design a UAV, we must be able to prove our capabilities in terms of numbers to our customers. The customers won't understand the science or the engineering stuff behind designing the UAVs. Only thing which they need is the product and its capabilities. This is where we'll be showing them the maximum speed which it can travel at, and the range and the endurance which it could provide, and many other technical stuffs like that. If it's satisfying their needs, they'll be funding us or they'll be procuring our products. Next is our detailed design phase. In detailed design phase, slowly our UAV will be starting to get into shape. From the preliminary design, we'll be getting into subsystem functional analysis, which includes our avionics, and if in case any mechanism which we use, it will also be validated. Then we'll be optimizing all the uh, design there, and if it's meeting our requirements, we'll proceed further on to component design. If it's not satisfying our requirements, we'll again iterate it. Once that's done, we'll be designing parts like our wing control surfaces, our tail, rudder and elevator and stuff like this. Once that's done, we'll be creating a mathematical model, and we'll be manufacturing a prototype. Once the prototype has been manufactured, we'll be testing it in real time, just to ensure its airworthiness and the structural integrity of the system. Moving on, next is the design review. Once we perform prototype testing, we'll understand how the flight is behaving on air. If we are satisfied with the performance, we'll be moving on to the documentation work. If it's not performing well, we'll be again iterating the complete detailed design phase from the start. If at last, kudos, we have got our performance satisfied, we'll be moving on to the release of documentation such as detailed drawings and everything for large scale production and assembly. Till now we have been learning about what are UAVs, how do they work, and different types in them. Now let us start looking onto the application of UAVs. The drone application ranges from entertainment, aerial photography, delivery, geographic mapping, disaster management, precision agriculture, search and rescue, weather forecast, law enforcement, and wildlife monitoring. Speaking about law enforcement, in the recent days when we faced COVID, drones were used to detect people on the streets, and it helped in forcing people to get back into their places. And aerial photography, everyone who's traveling around the country or who's having a vacation don't need a separate cameraman behind them, and they just need a capable UAV which will just get them very beautiful photos. And it also like goes on to be extending to precision agriculture. Speaking about precision agriculture, there it is an interdisciplinary concept where they use unmanned vehicles with combination of machine learning algorithm. Let us say we have a strawberry farm and the harvest time is around 6 months. What happens here is that they'll be flying the drone above the farm, and they'll be analyzing the health of the crops. For example, let us say in at the end of 2 months, once we fly our UAV, we'll be getting forecast about the amount of harvest which will be getting, the health of each and every fruit, and the level of water precipitation in the soil. Based on that, we can either spray fertilizer or pesticides, and proceed on with water supplements. This following video will be helping you create an idea about where all drones have been used in real time, and it is also a very good way of understanding how drones are being creating a very huge impact on the society. And hope the video was pretty much interesting, and it helped you gain some understanding about the applications of UAVs. And based on my personal experiences, I would like to share certain useful softwares which would be helpful while you designing UAV or any other field which you get into related to design. The first software standing here is Catia V5, which is a very powerful surfacing software, and there are some salient features when compared to other computer design softwares. And up next is ANSYS Workbench. ANSYS Workbench is generally used for computer-aided analysis, starting from computational fluid dynamics, static structural analysis, vibrational analysis, and its application extends to a huge range. Up next is Matlab. Matlab is a very powerful computation software which is similar to Excel, but again, it reduces your work to a huge extent. And fourth is Excel. And any design work which we did for our final year project, we made sure that the design process were parameterized in Excel. For example, when we were designing a quadcopter by ourselves, what we did is just formulated all the basic design formulas in Excel, and we were just plugging in values. Whenever we need iterations or whenever we needed to change any values, we were like simply changing the numbers there. And up next is OpenFOAM and Nastran. They're pretty much similar to ANSYS Workbench, but again, they are also pretty much like OpenFOAM is dedicated for computational fluid dynamics, and NASTRAN again is for internal structure design and different stuff. Up next is OpenVSP. OpenVSP is nothing but Open Vehicle Sketchpad, which is designed and developed by NASA. And this is pretty much a low fidelity. Low fidelity in the sense when we design an UAV at conceptual stage, we'll just come up with a surface model based on which we can perform certain analysis like your which is similar to your computational fluid dynamics and plug out some crucial outputs from it. And adding next is XFLR5. XFLR5 is again a low fidelity software where you can import airfoil geometry into it and get the coefficients such as CL and CD, which I had mentioned earlier. Xfile is a similar software where you can only do airfoil analysis, whereas in XFLR5 you can also carry out stress analysis, bending moment, and stuff in on a wing when it comes to XFLR5. That is how it's different from Xfile. Up next is DaveWin. It's also a software where you can design internal structures based on the loads you get. Last but not the least, it's Keyshot. Keyshot is a very powerful rendering software, which I encourage everyone to learn. Its application is not just limited to UAV design, aerospace, or mechanical engineering, but again, people in jewelry fields use this to render their designs and just showcase it to their customers. Up next is the online platforms which you can learn where you can learn all these skills from. The very first one is NPTL, National Program on Technology Enhanced Learning, which is jointly provided by different IITs and central government institutions in India. Up next is Coursera, which personally helped me a lot to learn. And if you need to get if you are not financially stable, you can apply for financial aid over there and get course access. And I can ensure that the course quality is very high and you can learn lots of stuff over there. And the next here is EDX. EDX is by Stanford University, and again it's very similar to Coursera, but again this also offers financial aid for students with the requirement. Up next is Udemy. Udemy is a very good online platform where you can buy courses for free, sometimes for free and sometimes for at cut-off cost. And I learned certain softwares like Catia and Keyshot and Udemy. Moving on, it is MIT Opencourseware. MIT, you might have heard about it. It's nothing but Massachusetts Institute of Technology based in the United States of America. The course contents provided by their professors is of very high quality, and it's it's of no off cost to learn from it. And you get the coursework, the assignments, and all the course details from the website itself. Just Google it as MIT Opencourseware and you'll get access for everything. Up next is the internship opportunities. Whatever we learn theoretically comes into or gives us fruitful outputs only when we do hands-on work. For example, UAV design, how much have I did Nptel courses on it. Once I got into my internship experience, I started learning a lot. It's just because whatever I learned theoretically, I was able to implement it here. So some of the internship opportunities for third year and fourth year, which is nothing but pre-final year and final year students, is a search program which is provided by IIT Kanpur, and they provide internship with stipend for 2 to 3 months. Next is Spark program by IIT, Indian Institute of Technology, Roorkee, and they also provide you stipend. And also it is a very good exposure for you to visit these institutions and learn stuff from there. Up next is Summer Fellowship program, which is provided by IIT Madras, and Indian Academies of Sciences research program provided by the Indian Institute of Sciences collaboratively for labs across India. And the next two are international internships, which is MITAX, Canadian internship, and India Connector, NTU, Singapore. This is hope it was it's an insightful session for everyone, and thank you for providing me such an wonderful opportunity to share all my experiences and to do knowledge transfer from my side.
Thanks are the highest form of thought, and that gratitude is happiness doubled by wonder. Thank you, Mr. Pradeep, for your outstanding discussion. We have now reached the end of this session, and this is the time to extend our gratitude for the successful completion of today's event, Unmanned Aerial Vehicles. No duty is more urgent than that of returning thanks. I deem it my privilege in proposing the vote of thanks. At the outset, I would like to extend my sincere gratitude to the management for providing an opportunity and extending full support to organize such an event. I would like to thank our principal sir, Dr. S. Ramachandran, for being a source of motivation and guiding us to conduct such events. I would like to thank our most eminent speaker, Mr. Pradeep, for spending his time with us and enlightening the stay with his knowledge. Profound thanks to the event organizing committee for playing a pivotal role in organizing and ensuring the smooth conduction of this event. I also thank all participants for accepting our invitation and extending full support. Dear participants, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificate. The participation certificate will be mailed to your registered mail IDs within few working days. Thank you. I would like to complete this day with the final quote. Live a life full of humility, gratitude, intellectual curiosity, and never stop learning. Once again, I thank you all.
So with that, we'll move on to the Kahoot quiz. Okay, so I request all the participants to kindly open your browser and type www.kahoot.it and enter the gaming pin that is shown on the screen. That will be 2667098. I request all the participants to open their browser and enter the website ID www.kahoot.it and enter the gaming pin number 2667098. I'm waiting for the participants to join the session. So once again, let me repeat the Kahoot number. The gaming pin number is 2667098. Wow, that's nice. We have 5 participants so far, and I'm waiting for another 5 or 6. Oh, someone has joined the Teams. We'll wait for a few minutes and let us start the Kahoot. Let me repeat the gaming pin number 2667098. We have just one to go. Let us see who will be it. One more and we'll start the Kahoot. So let me repeat the gaming pin number 2667098. And we have 10 of them joined, so let us start the Kahoot. Welcome to Saturday's Kahoot. So our first question will be in 3, 2, 1. And the question is, what is the full form of UAE? Okay, unarmed aircraft vehicle, unmanned aerial vehicle, unmanned aeroplane vehicle, unmanned aircraft vehicle. We have 17 seconds left. Let's see who answers it. We have already 6 of them answered right. So let us see how much time it takes for the others. Oh, we have all the 7. Okay. So the right answer to it is unmanned aerial vehicle. And about 9 of them has answered it right. I'm sorry about that. Yeah. So we have Praveen on the top with a score of 948. So that's great, followed by Maha and Vidit. So the second question is, which of the following category of drones does not require registration for use in India? Nano category, micro category, small category, large category. and 3 of them have already answered it. 20 seconds left and 18 to go. Let us see how many of them answers within. Okay, we have 10 seconds left now. And we have, the answer is nano category. So let us see who is on the top. Okay, Praveen remains on the top, followed by Nitu and Sasikala. That's great. Moving on to the third question. Which of the following is not a type of drone based on aerial platform used? So the options are multi-rotor drones, single-rotor drones, moving-rotor drones, fixed-wing hybrid VTOL. So your answers are 15 seconds left. And the answer is moving rotor drone. So let us see who is on the top this time. Wow, it's Praveen on the top, and Bablu has come up in the scoreboard, followed by Nitu and Kesh. So the next question is, which of the following is not a subtype of multi-rotor drone? Twin copter, tricopter, quadcopter, quadcopter. So your answers are, we have 15 seconds left. Okay, all 10 of them has answered. So the answer is twin copter, and 6 of them has answered it right. And Praveen remains on the top, Nitu followed by Nitu and Sasikala. And it seems certain people have gotten down. Buck up, people, buck up, you can do it. So which of the following is an application of drone? Project monitor, aerial mapping, structural health monitoring, all of the above. So this answer must be pretty clear to you guys. And I'm hoping all of them answer right. So all the 10 have answered it. Let us skip it. So the answer is all of the above. That's great, as I thought. So Nitu has come up with a score of 4674 and Pravin with the score of 3758 and followed by Sasikala, who has remained in the place. That's great. So the next question is, which of the following is considered as the fourth dimension according to 4D printing technology? Speed, velocity, weight, time. This is again an easy question, I guess. So let us see how many of them answers it right. We have 15 seconds left. 12, 11, 10, 9, 8. All the 10 have answered it. That's great. Moving on. The answer is time, and 6 of them has answered it right. And Nitu stays on the top, followed by Pravin, Vidit, Kesh, and Bablu have made it to the scoreboard. So the next question is, which of the predecessor technology to 4D printing technology? Okay, the options are offset litho printing, 3D printing technology, flexographic printing, digital printing. We have 15 seconds left and already 6 of them have answered it. So I'm hoping maybe it's an easy question again. Wow, that's great. All the 10 has answered it. Moving on, the answer is 3D printing technology, and 4 of them have answered it wrong. Okay, 5 of them. It's a 50-50 ratio. Ritu has been staying on the top with a score of 6611. Vidit followed by Vidit and Partha by Sasikala and Praveen. Moving on to this third last question. Simulation software developed by Autodesk for 4D printing technology. Cyborg, AutoCAD, Fusion 360, Catia. So the answer is, we have 15 seconds left and already 6 of them have answered it. That's great. That's a great count, guys. That's pretty fast. Okay, the answer is Cyborg. And 9 of them have answered it right. And Nitu stays on the top with a score of 7573, followed by Partha 4748, followed by Praveen 4707, followed by Sasikala and Vidit. On to the second last question. Choose the area where smart materials can be applied in future. healthcare, robotics, industrial manufacturing, all of the above. Okay, this is more of a general question, I guess. Even I know the answer. Let us see if my answer is right. Okay, we have 9 of them answered it already, and we have 10 seconds left. Book up, people, book up. 5, 4, 3, 2, 1. And the answer is all of the above. That's right. All of them have answered it. Wow, I really appreciate it. Nithu is on the top, followed by Partha, followed by Sasikala. That's great. On to our last question. Choose the stimulus which can be used as a stimuli for smart materials. The options are temperature, force, electric signal, all of the above. And your answers are? Okay, 9 of them have answered it, and 10 seconds left. We have 5 seconds left. That's great. All the 10 has answered it. It is all of the above. So let us see who is on the top podium. On the third is Vidit with a score of 6474, and followed by Partha with a score of 6520. And the top goes to Nithu with a score of 9474, 10 out of 10. That's on point. And the runner-ups are Sasikala and that went on. Okay, so congrats to all the winners and the participants for your effort. Thank you. See you another day.
Thank you, ma'am, and thank you, one and all.